Hi, and welcome to this video on Lambda expressions and its use cases. Hi, I'm Raghavendra, an expert in AI, ML, and data engineering. By the end of this video, you will be able to understand Lambda expressions, demonstrate how to use Lambda expressions in map, filter, and reduce functions. Lambda expressions are anonymous functions which are not bound by any name. It's restricted to a single expression. It's executed inline and it does not have an explicit function call. Please note, Lambda expressions is comprised of a very simple piece of code, and any complicated code within a function, you can't implement that using a Lambda, and you would need to go for the traditional user-defined functions. Let's create a Lambda function object. So Lambda is the keyword. X and Y are the arguments to this Lambda. Colon follows the single line body of the Lambda function where we are computing x plus y. Let's create this Lambda function object. And this Lambda can be used in any function or any operation which requires a function object. So now, to execute this or to invoke this Lambda inline, we put this Lambda code within small brackets, followed by the arguments to the Lambda within another small bracket. So now 3 and 2 will be passed as arguments to this Lambda, and this Lambda is going to compute the addition of these arguments 3 and 2. Yep, here you go. You have a value of 5 which is being output from Lambda. So Lambda can be used in any function which require a function object as an argument, and these Lambda expressions are extensively used in functions such as map, filter, and reduce functions. Let's now understand what is map. Map is a function in Python to apply an operation on every element of the collection. Map function takes two arguments. The first argument is a function object which represents the operation to be performed on every element of the collection. And this argument can in fact be a Lambda as well. The second argument is a collection on which the operation is to be applied and which is usually a list. So let's take our first example where we are going to apply a square operation on every element of a list. So here is a list, a numerical list, and here is our map function, and this is the first argument to map, which is a Lambda function, and the second is the list. So what are we doing here is we have this Lambda keyword, an argument a, and this Lambda function body takes the square of a. So where a here represents the individual elements of this list. Let's see by executing this. So map function returns a map object which is not iteratable. To display the output of map, we will have to convert it to a list, and here is the code. Yep. So you have all the elements of the list, input list, which was passed as an argument to map, is now being transformed by taking a square of every element. So what we are typically doing is this function over here, represented by Lambda, where we are taking a square of a number, is being applied on every element of this collection over here. And it returns a map object which is then converted to a list, and you see the output over here. Let's take another example where we are trying to divide every element of a list by 100. So here is the list. So to the map function, we have a Lambda representing the operation x divided by 100, and x is the argument to Lambda, and the second argument is the collection. So the map object is then converted to the list. Let's see the output. You can see this operation x divided by 100 represented through lambda is being applied on every element of the collection. And you can see every element of the list is now being divided by 100. Here is the final list after dividing by 100. So map is an abstraction over iteration. You need not have to explicitly iterate a collection to apply some operation like taking a square of every element, dividing every element, and so on. You can instead use the map function. Let's next move on to filter function. Filter is used to filter or choose the elements from a collection based on a condition. The function takes two arguments, a function object which specifies a condition for filtering the elements from the collection, and the second argument is the collection. The outcome of filter would be only the elements from the collection which satisfy the condition represented by the function object. And note that function object can as well be represented by a lambda expression. So here is the list. So what we do is we call this function filter, and here is the lambda where we have an argument to lambda x, and this is the condition x mod 10 equal to 0, and this function or this expression is going to be applied on every element of the collection, and it's going to give us a boolean values true or false, and finally whichever value satisfies the condition is going to be filtered out from the collection. And output of filter is going to be a filter object which we are going to convert it to a list. I am saving that list in an object div 10, and here you go is the output. Here you can see only the elements which are divisible by 10 are being printed out. Now for every element of this filtered list, we are going to apply an operation, that is for all the numbers which are divisible by 10, we are taking a square of it. So here is the map function which we are going to use to achieve this task, and we have the lambda over here representing the number to the power of 2, and here is the filtered list, that is div 10, and the final output is being converted to the list. So here is the output where we have taken this list of numbers divisible by 10 and we have taken a square of every element. So what did we do here? We took the input list and we filtered it out by taking only elements which are divisible by 10, and to those elements we mapped an operation by taking a square of every element. The next is the reduce function. To apply pairwise or an aggregate operation like sum, multiply, min, max on a collection, reduce function is going to be used. Reduce function takes two arguments, a function object which specifies the aggregate operation to be performed and a collection. The function object specifies a pairwise operation or an aggregate operation and hence takes two arguments. Please note here the lambda here to reduce will have to take two arguments which represents the arguments to perform the pairwise operations. So to use reduce, we will have to import that from functools. We are doing that in this line. Then here is a list of numbers. So we have the reduce function. The first argument is a lambda taking two arguments and representing the operation x plus y where we are adding numbers. So the second argument is the collection. So this argument x plus y denotes two consecutive elements of a collection. So we're going to add 3 plus 4 and the result of that is added to 5. The result of that is added to 6. Result of that is added to 7 and so on. Right? So we are going to perform pairwise operations, and finally the conclusion, the outcome of reduce is going to be, in this case, the sum of all the elements of the collection. We have one single line of code a neat code where we are using reduce with Lambda to compute sum of the elements of the collection. So now, since we have the sum of all the elements, let's compute the average by dividing it by the length of the list. Next, we are taking another example where we are taking a list comprising of zeros and non-zeros. We are going to clean the list by removing the zeros. Then we are going to multiply all the elements of this cleaned list. And then we are going to find the min and maximum element from this cleaned list. And for most of this, we are going to use filter and reduce functions. So here is the list of numbers. So we are going to filter out all elements which are not 0. So here is the filter function. The lambda, I specify this condition in the lambda expression, and the second argument is the list. So this condition is going to be applied on every element of the list, and you're going to filter out those elements which satisfies the condition x not equal to 0. So I'm going to convert the filter object to a list, and I save it in list underscore clean. So here you go is the list where all the zeros are being removed. So reduce, I pass the first argument as a lambda object with two arguments x and y representing multiplying x and y, and this is going to be applied on the cleaned list. So you're going to multiply 7 with 19. The outcome of that is going to be multiplied with 3. The outcome of that is going to be multiplied with 2, and so on. So you end up multiplying all the elements of this cleaned list. Here you go. You get 11970, which is the product of all the elements of the cleaned list. Then we are going to compute the minimum element. We are going to compute the minimum element out of these cleaned list of elements. So for that, we are going to supply a lambda expression which says x if x is less than y, else y, where x and y represents two consecutive elements of the collection. So your lambda is going to be applied on these elements. So between 7 and 19, you're going to have the least of the elements, that is 7. Between 7 and 3, again the least, which is 3. Between 3 and 2, the least, and so on till the last. So at the end, you're going to end up getting the smallest element from the collection. So here you go. You have the smallest element from the collection, which is being returned as an outcome of reduce, that is 2. Likewise, we are going to figure out what is the maximum element from the collection using reduce. So here is the lambda. So we are going to return x if x is greater than y, else we are going to return y from this cleaned list, which is supplied as the second argument. So what happens is that between 7 and 19, you pick up the maximum. Between that output, that is 19 and 3, you pick up the maximum. Between 19 and 2, you pick up the maximum, and you repeat this exercise till the last. So you're going to get the maximum of all the elements of this cleaned list of elements, that is 19. Before we conclude, we have a small piece of code, a very interesting piece of code. So I take n as 8, and I'm going to generate a list of numbers from 1 to 8 using the range function, convert it to a list, and I save it in this object lst, print it out. Here are the list of numbers from 1 to 8. I'm going to use reduce, where I am specifying an expression to multiply the elements of this collection. So let's see what the output is. You see the output as 40380, which means that you are multiplying all the elements from 1 to 8. Is this not same as 8 factorial? Yes, this is. This is the simplest way of computing the factorial of number using reduce and representing the computation of multiplying numbers using lambda. In this video, you have learned lambda expressions are anonymous functions which are not bound by a name. Lambda expressions are executed inline, which does not require a function call. Lambda expressions can be used in any function which require a function object as an argument. Lambda expressions are extensively used in functions like map, filter, and reduce functions. Thank you for watching this video.